So my name is Zander Hume, and I'm a video game composer. I'm currently studying my Master of Fine Arts at QUT. I'm working on a new method for adaptive music in video games. And so my master's project is a proof of concept showing that you can manipulate musical dynamic, which is not something that's been done terribly well so far. But anyway, we'll find out about that. So my method is called music shingling, and I'll tell you all about that in a moment. Okay, so basically you've got three types of music in video games, right? You've got non-dynamic music, just plays, does its thing. Interactive music, which is triggered by player actions, and then adaptive, which is music which responds intelligently to player actions. So I've got a couple of examples here, just to illustrate that point. So, got good old Alex Kidd in Miracle World. Simple theme, plays through. When it gets to the end, it starts again. It loops and loops. Just get that. Nothing groundbreaking there. Well, it was pretty impressive at the time. Now we have Ocarina of Time, which has, not that bit. Before that, I believe. Here we go. So, you come to this screen and you go, oh, some kid told me this tune, and now you've got to learn to play the tune on your controller. And it goes like this. So you're given your instructions. You go, right, this correlates to this thing I'm holding in my hand. And as you press the buttons, you hear the notes on screen, right, being played by the music engine, which is cool. That's interactive, right? Next we have adaptive music, which is what I'm really focusing on. And in Portal 2, we've got some really, it's an excellent soundtrack in Portal 2, and it has some excellent adaptive music features. So, what we have going on here is a puzzle, and as you solve steps in the puzzle, new layers are added to the musical backing. So you'll hear when he puts the first laser into the receptacle, this first layer of music happening. Now, as you solve the puzzle further, you get extra instrumental layers, but the really cool thing about the way they've done the sound in Portal 2, as well as that, is that it is in fact, instead it's not 2D, it's 3D. So all of these synthesized sounds appear to be coming from the puzzle elements. So it's all in 3D space around you, as if these things were playing the music, which is pretty damn cool. So that's not actually you pressing a button and it making a sound. That's, you know, an intelligent response to game state changes, right? So there's lots of different ways and different things we can change adaptively in music, in games, which is really fun. But musical dynamic is not one that's really been properly done, right? So you'll notice in that past clip, not that it was very loud, that as you get further away or close, that the volume is changing. And with synthesizers, you can't really so much tell the difference between volume and dynamic. But volume and dynamic are very different. So if I'm speaking softly, then the timbre of my voice is very different to if I'm shouting or speaking loudly. And in music, that's hugely noticeable, especially with acoustic instruments. And so I really want to look at how can we make dynamics of a violin or something that's so expressive change adaptively in response to the gameplay. Okay. Now, there is a reason why we can't do this at the moment, and this is because of this going on here. So, two classes of audio in video games, right? You've got classic old sequenced or generated audio, you've got a PSG in your console or whatever you're doing, and that receives MIDI information or basically, you know, code, and it makes that into waveforms and produces the sound, right? On the other side, we've got pre-rendered audio, which is you make a CD or whatever, you know, you record sound, that is your sound. It's a waveform, and the game engine triggers that sound. It doesn't generate the sound. And they've got pros and cons there. But basically, sequenced, really easy to manipulate because you're changing the code. A lot of fun to manipulate in that way as well. But you can't have real sounds, right? Pre-rendered, you've got that full, lush. You could have an orchestral score for your game, which a lot of people do, but you can't manipulate it quite as easily. It's very difficult to change tempos, all that sort of thing. So what are they doing about this with pre-rendered audio? We've got the two main ways of making pre-rendered audio adaptive are horizontal resequencing, which is where you write a whole lot of different musical sequences which all have transition states which run from one into the next. So you're walking along, you're in the woods, you've got woods music, you walk into a cave, there's a transition, it goes into cave music. Or it'll crossfade into cave music or something, right? Not particularly sophisticated. Vertical layering is what we heard in Portal 2. We've got different instrumental layers which become louder or softer or start or stop depending on game state changes. So there could be, you're walking along in the woods, it's nice and peaceful, but then suddenly you hear drums, and you think, Christ, what's going on? Is there something near me? Okay, so part of what you do with, well, I guess the big problem here, right, is that if we want to change the musical dynamic, we want to go from a track that's going do-do-do-do-do-do to one that's going ba-da-da-da-da-da-da, and we want to move really quickly and dynamically through that, we have this problem here with tiling, where we've got our softer, quieter sound moving into our larger, bigger sound, and we have the reverb tail gets cut off. Reverb tail is a real pain in the ass. And it doesn't look like much, but the human ear is incredibly receptive to all this kind of stuff. So basically after a sound, when I finish speaking, you hear a slight echo and reverb from my voice. And if you heard me finish a word and then that reverb gets cut off in the middle, it sounds really weird, and your brain immediately goes, this isn't real, this is fake. And so to improve game immersion, right, we don't want any of those sort of moments happening where you suddenly get snapped out, distracted by something going, oh, that sounded weird, or that was wrong, that was fake, right? So what I'm trying to do is maintain the reverb tails, the end of the sounds from previous bars of music, right, and overlap them into the new bars, which is easier said than done. So I'm sort of stealing my concept somewhat from Ben Hogue, who did the soundtrack for some pretty cool stuff, but also for Tom Clancy's End War, in which he used a pretty ambient sort of style, various sort of bits of music that can just sort of go together and overlap, and not very structured standard formal music. But what he did is that he had a bunch of different sounds, and they would play to their completion and have their reverb tails still ringing out when the new sounds are introduced. And of course he did this on an Xbox, so he had lots and lots of processing power and RAM to work with. I'm trying to achieve something that's a bit more linear, and I've decided to limit myself by working on the mobile platform, which is a terrible idea, but it does let me really try and refine this idea to make it work with as very little processing power as possible. So all I'm doing is running 2 tracks at any given time, and you'll see we have these things overlapping. And then music's playing, you get a trigger here, we know to swap this piece out for a louder bit of music, so it gets to there, trigger it again, we know to get louder, and moves on like that. Overlaps, really nice, you hear the na 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 da 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 do do, and it sounds natural. That's the plan. Haven't quite done it yet, but that's what I'm working on. And the other part to this method is not just the programming of making that happen, but also a technique of writing and recording the music. So I'm also work as a music producer, and I've got to try and write this music so that my performers only play every second bar of the music. Because I want this to respond really quickly, hopefully within a second is my plan. So if I record my music in half-bar chunks, rather than recording the score in the studio, I'll record the score with the musicians. Sort of, it'll be a bit awkward for them, but I have to work this out. But they'll play like da 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 dum da 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 dum da da. Basically pausing at every breakpoint, and so you hear the natural reverb of the space tailing out into that nothingness, and then I'll cut it all together, so that overlaps like this, right? I've recorded bar 1 and bar 2, I've chopped them and put them next to each other, so that even though when they were playing they stopped there, and you hear that reverb tail overlapping with the next bar, that's a reverb tail you would expect to hear if they're playing it sequentially. So, as preliminary work to get this happening, I've been working with Protostar, with Dean and Matt, which are fantastic, and I worked on this game we're going to release soon called Sling Kong. And for this, thank you, I made a soundtrack with tiling. So you hear drums first, then shaker gets added, then bass line. Now you hear the ooh, ooh, ooh kind of thing going on. Eventually get up higher up in the level because it's a vertical climber. The higher you get, the more instrumental layers are added, but not through vertical remixing, through just sequencing tiles. But anyway, so that's how that works. And basically that is the same as what I'm planning to implement code-wise, except I'm not having that overlap yet. So I've built a sort of an adaptive music engine for that in C# that runs these tiles in place. And my next step is to the next game we're working on, which will be my master's project game, called Bear Rescue, which I'm making with this guy here, and his brother as well. And it's just going to be a simple puzzle platformer, but basically we've got our two characters, and the bear on the right will kill you if he touches you. So we wanted to increase musical tension the closer the bear gets to you. So as the bear gets closer, it triggers the music engine to play more and more aggressively dynamic music. And as you get further away, it gets more relaxed and safe sounding, basically. So that's what I'm working on at the moment. And that's hopefully all going to have some good implications for future games work. I mean, obviously this example is just for musical dynamic, but I hope to in the future take it further into manipulating various other musical elements, which we currently can't adapt quite as quickly, without obvious cross-fading and other stuff like that. We really want that player immersion to remain in this, I'm hearing a piece of music, and this is just how the piece of music goes, and it seems like it's mapped nicely like a film score to the gameplay without ever hearing, okay, now I've got the fade into the next bit, or this kind of stuff that triggers your mind to suddenly realize, wait, this isn't real. This is being manipulated. So, that's the plan. Thank you. Do you have any questions? I think I've got like a minute left or something.
Yeah.
Yes?
When you were talking about musical dynamics,
Mm-hmm.
have you looked at all, can that be done with synthesis?
Yes, you can do a bunch of stuff with synthesis. I'm really wanting to look at how to do it with acoustic instruments. But yeah, there's so much really cool stuff you can do with manipulating synthesizers, and a lot of it is being done. And I'm always really excited to find games with really cool adaptive music. But yeah, something I found hadn't been done really well yet is acoustic instruments, like symphonic stuff, adapted in that way.
Have you looked today on physics in instruments like Piano Tech and those sort of things where they do a full physical simulation of an acoustic instrument?
I have looked into that kind of stuff, and also even just like instrument sample libraries and stuff like that. And it's a bit heavier in terms of processing current.
On a multi-core machine.
Yeah. So I really wanted to see how simple and how easy for the computer to work we could do this, because then you can layer it up with these other techniques like vertical remixing and other stuff, whilst not hugely increasing your processor load and RAM usage and everything. So, but yeah, those things are so cool.
Yeah. Are there any that you can embed directly in a game engine?
I'm really not sure. I haven't looked into that kind of integration yet.
Okay.
Yeah. Oh, yeah.
I think it's a lot of fun.
Yeah, that kind of stuff is really cool. Yeah. Well, anything else? No? Oh, yes?
Is it going to be
Oh, sorry?
sorry, is it going to be an easier like version just to say like you got the code, you go set intensity or something like that, or set staccato so it breaks up with stuff or something along those lines that people that just want to.
That'd be really cool to do in the future. This is a master's project, so I've only got till the end of this year to finish my thesis and everything, which is a bit stressful. But what I will be doing is making all of my code and everything available for people to look at, to use. It's not going to be easy to use, but I would like to develop a thing. The trouble is that you have to record it in a specific way, so you can't take your pre-rendered music and then apply this to it. You have to make the music with this in mind, because it also puts certain compositional sort of constraints on you as well.
Yeah, you pretty much answered my question there. I was just going to ask if you had to re-record the music, but I was also going to say that this is almost making me think like it's rendering audio, the same way that we've come along with graphics, and we've had all these different ways of doing that. And this is just a new way of generating the audio, and I think people will take that thinking and really, take it places like you were doing. Cool.
Cool.
Do you have any thoughts about using it in conjunction with something like live looping? Just as complete left field.
I haven't actually.
I'm actually working on porting a live looper from an old code base to a new code base.
Oh, yeah?
Just thought there could be some very interesting things with.
Oh, give it like various little overlap parameters so that it maintains
so with
things.
looping, you can get some of the same sort of transitions and things like that.
Oh, that's a really cool thought, but no, I haven't. Thank you.
You've just blown out his master's.
Yeah, he was.
All right, PhD, here we go. Alrighty, cool. Well, I'm sure I've gone over now. But thank you, everybody.